Okay, so today we're going to start by doing another little recursive sequence here. And then I'm going to present a problem to you that exists with our current notation for these sequences. Our recursive formula starts with our first term. And so if I'm looking at this, what's happening from going from each term to the next? You probably figured this out by now already. It's plus 20 each time, right? And so u sub 1 is 20. I add 20 to get u sub 2, which is 40, and so on, and so on. So when I write my recursive formula, that's going to be u sub n equals u sub n minus 1 plus 20, because I'm adding 20 each time. Okay? Now, I can use this to find any term in the sequence. If I wanted to find the fifth term, u sub 5 for the fifth term, I take the fourth term, u sub 4 plus 20. U sub 4 is the fourth term, which is 80, plus 20 to get 100. Now I'm going to show you the problem with this. What if I wanted to use this recursive formula here to find u sub 1? If I'm trying to find the first term, that tells me that I would take u sub 1 minus 1 plus 20. That would give me u sub 1 equals u sub 0. But this is our first term. We don't know what u sub 0 is. As a matter of fact, we've never even heard of u sub 0. So our recursive formula in this form only works when n is greater than or equal to 2. And so this is actually part of our formula. So now that you've gotten used to recursive formulas, from here on out, whenever we see this, it is only going to work if n is greater than 2. Oops. Did something wrong. So it's if n is greater than or equal to 2 is the only time it's going to work. There we go. So each time that you list this recursive formula out like that, u sub n equals u sub n minus 1 plus 20. You could say if n is greater than or equal to 2. Without that n are greater than or equal to 2, these recursive formulas don't work. So it has to be in there. That takes us to the alternate sequence notation. Sometimes it's going to be more convenient to begin numbering the terms of a sequence with a number other than 1, such as 0, or sometimes you even want to start with a number like 4. Simply based on what we're looking for and how it starts. If we look at this word problem coming up here, and again, I'm rushing because you're not in the classroom, which means that you can just pause this at any time. A ball is dropped from a height of 9 feet. It hits the ground and bounces to a height of 6 feet. It continues to bounce, and on each rebound, rises to 2/3 the height of the previous bounce. Write a recursive formula for the sequence that represents the height of the ball on each bounce. So here's a situation where if we try to write our sequence, it's going to mess it up using our normal sequence notation. If I start with u sub 1 and say that's 9, that's not true. Because this is, u sub 1 would be after the first bounce of the ball. I'm dropping a ball from 9 feet. It bounces up 6. So this is actually my u sub 1 coming up 6 feet. Our original was at 9 feet. So now you see that the problem that our normal notation would have. So I'm going to go back and use an alternate sequence notation. My u sub 0 is my original. That's before the ball ever bounced. So 0 bounces in, it's at 9 feet. U sub 1 is at the first bounce. It's at 6 feet. What could we say for U sub 2? It says it's 2/3 the height of the previous bounce of the ball. So if I take 6 and multiply it by 2/3, sorry, I made that come up too high. 6 times 2 is 12. Divided by 3 is 4. So U sub 2 would be 4. If I do 2/3 of that, for U sub 3, I do 4 times 2/3. That gives me 4 times 2 is 8. 8 divided by 3 is 8/3, which is equal to about 2.66 feet. Repeating. And I can keep going with this. But by now we should have our sequence. So if I write the recursive formula, it's U sub n equals U sub n minus 1 times 2/3. Or I could just do U sub n equals 2/3 of U sub n minus 1. So that this is our formula for the height of the ball. Now, because I've numbered this in U sub 0 form, if I'm trying to find U sub 1, that would be equal to 2/3 of U sub 0. I actually have a U sub 0 here, so I don't have to put any restrictions on this. 2/3 of 9 gives me 6. That's how I would come up with my first bounce. Now let's create a table and a graph showing the height of the ball on each bounce. So let's create the table. I'm going to go ahead and draw one in. Make it a little bigger. Okay. So U sub 0 was 9. U sub 1 is 6. U sub 2 is 4. U sub 3 is 2.66. Now, how do these terms of the sequence relate to a graph if I was to graph it based off of this? So I'm going to pull up Desmos. And I'm going to put the graphing calculator. And I'm going to start plotting these points. By the way, you can do this split screen by just grabbing this top and pulling it over to the side of the screen, and you'll see it split in half. And then you just drag it, the other one, to the other side. So these terms of the sequence relate because U sub 0 is going to be my x, which is just 0. So 0, comma 9. Close my parenthesis. Now I can enter in 1, 6. Two, 4. And 3, 2.6 repeating. I can even do 8/3. That'll be even more accurate. You'll notice I have to push the over button. Like when I type this parenthesis in here, after doing 8/3, it went into the bottom. I have to push the over button to get it back to normal. So now we can look at this graph because it wants us to find the height of the ball on the fourth bounce. You can see it's kind of curving down like this. I can zoom in. I can even make my equation go away so that I can grab it and look at it better. If I was to look at where this is trending down towards, just follow the pattern, it's looking like it's going to be right around 2 feet on the fourth bounce. Maybe even a little lower. So right around 2 feet would be my guess. Just from looking at the graph. We can actually do the calculation. And we can do it right here in Desmos. Just go to Math Tools and Scientific Calculator. And I can do 2 divided by 3 times. Now look, it put the times in the bottom. So push backspace, push the over arrow, and then times. And then I'll do 8 divided by 3. So that's taking my u sub, or my 2/3 times my u sub 3 to find u sub 4. You get about 1.77. And so if we look back at our graph that I already made disappear, you could have, if you would draw that trend line in, you would see it was a little bit lower than 2, which was my prediction for it. So the height of the ball on the fourth bounce is actually 1.77 feet. So u sub 4 is 1.77. Salary raise sequence. If the starting salary for a job is $20,000 and a raise of $2,000 is earned at the end of each year of work, what will the salary be at the end of the 6th year? Find a recursive function to represent this problem and use a table and a graph to find the solution. So this is kind of the same thing. If I'm starting this one, I don't want to start at u sub 1 because that's at the end of my first year and I'm getting my first raise. So for the 0th year, or your entire first year until you get that raise, you're going to be making $20,000. So that's why you start at u sub 0, because that's your start day. You've worked there 0 years at the start. U sub 1 would equal 20,000 plus the 2,000, so 22,000. U sub 2 equals 22,000 plus 2,000 more, 24,000. So now we can write our recursive function. U sub n equals u sub n minus 1 plus 2,000. Because it's going up by 2,000 each year. Use a table and a graph to find the solution. So we can make our table. I won't need all these spaces, but 0 stands for u sub 0, and that's 20,000. Then 1, 22,000. 2, 24,000. And now I'm going to go into Desmos and put those values in. You know, if you actually log into your Desmos, like create a free account, log in, it's going to make it nice because you're going to be able to actually go into the graphing calculator. And because I'm in here, now when I plot my points, zero comma 20,000, 1 comma 22,000, 2 comma 24,000. Now look, if I look at my graph, I don't see any of this. And it's because we are not scrolled out nearly far enough. We're talking about 22,000 and we're only at thousands now. So you just keep scrolling out. This is some of the limitations of Desmos. Because I'm scrolled out so far on my y-axis, my x-axis has also scrolled out just as far. So each one of these lines is now not worth 1, they're worth 1,000. If I go into my tools, it says step, so I'm clicking the wrench. The y-axis, I can make this whatever I want. I'm going to make the y-axis go from 0. Actually, I'm going to make it start at 20,000. We'll do 18,000 because I want it a little bit below where we start, and we'll make it go up to 30,000. Now it says step. That's how I can set how much each one of my lines goes up by. So my step, I'm going to make 2,000. My y-axis, I'm going to go from -1 because we can't have worked at a place less than 0 years. I can't work at a place -1 years. Like, okay, I've worked at Google for -1 years because I've never actually worked there, but that would just be 0. So -1 years does not make sense at all. So we can go from -1, and let's just go up to 8. And now our step, we'll make that go up by 1. So now I've set my graph so that it's relevant information to me. So that at 1 year, it went up to here. 2 years, it goes up to here. And now I can see it's going over 1 and up 1, over 1, up 1. 3 years would be here, 4 here, 5 here. Now 6 is off my graph, so I can just grab it and move up. And you'll see like my 5 comes with me, so I can see where I'm at. See, I still have 5 down here. So 3, 4, 5, and the 6th year is going to put me at 32,000. So it's much easier than calculating each one each time, continuing to go. I can trace kind of my line that is fitting this data and going up to year 6 at 32,000. So using that, I can tell that year 6 is going to be 32,000. And I don't have to do all the computations in between. Now, would it be a big deal to just add 2 until I get up to 6? Add 2,000 to it? No. But what if I asked you to find, what would U sub 30 be? So after 30 years, yeah, it's not going to be very fun to go through and track that. Now, because I'm logged into Desmos, I can export this graph as soon as I stop writing on it. Okay, I can export this graph as an image. So it would actually save this graph for me, download it right to my Chromebook, and you can drop this right in your assignments. So that makes it nice, convenient to do as well. You could also just email me this. Another thing you could do is click copy, put this link right into your document when you send me your homework. Put the link in there and type like problem 8 before you send me this link. And whenever I would click this link, it's going to take me directly to your graph. So you can share this with me so that I can see it. Just some of the things that are convenient with Desmos. So if I'm asking you to graph something, you go on Desmos, make sure you sign in, it's a free account. So you sign up for it, free account, and you can access graphs, export them to me, and it goes right into your assignments. Okay, watch for the new homework assignment coming.